You have just been promoted to sales manager of a company that manufactures robots used to assemble automobiles. Although your sales force is given a suggested price at which to sell the robots, they have considerable leeway in negotiating the final price. Past sales records indicate that sometimes there's a large difference in the selling prices that different sales reps can negotiate. You are interested in knowing if this difference is significant, possibly because of a more effective negotiating strategy or exceptional interpersonal skills, or whether this observed difference in selling prices is just due to random variation. You decide to randomly select 4 sales over the last year for each of your 3 sales representatives and observe the actual selling prices of the robot. The table below shows the amounts at which the robots were sold in thousands of dollars. So here is our data table. We have a column for each salesperson. It's a rather small data table. Each person has their own column, as I said. And ultimately, what we want to do, as it mentions here, it says, based on the results of your survey, can you conclude that there is a significant difference in the average selling prices that the 3 sales reps have been able to negotiate? Use a 0.05 significance level. So again, we're looking for a difference. This will inform our hypothesis statements. And also just keep in mind that we're looking at the average selling prices. You can see right here with the data above, it's quantitative measurements in thousands of dollars. So we're going to see if there's a difference in their averages, or their, we could say more formally, the means. So this means because we have more than 2 groups, we have 3 salespersons here, that we're going to do an ANOVA test. So let me write the hypothesis statements out. So the null would be that the first salesperson's mean is equal to the second salesperson's mean and the third. So we still have that idea of equality in the null. The alternative hypothesis is at least one of the means is different. And that's, I wanted to test about this difference. So that's the alternative when you're working with the ANOVA. And that's, I'm just put a little star here. That's the motivation of why we're doing it. We're kind of interested in whether the null or what's going to come out the null or the alternative. But our alternative is what informed the test, this idea of difference. All right, let's go to our guru. So I want to come here and let's do a data table, or a data set. And it really doesn't matter how many rows and columns I have. This should be plenty big. I'm just going to kind of bring this down to something like 20 and 3. I probably don't need 200. So here we have it. I'm going to come in. What I did was just simply copy and paste that data table you saw in the prior slide. And I'm just going to do a Control V here. And I have all 3 of these sales reps here. And what I would like to do is, because our guru will not understand that each rep is in a separate column, we need to stack these reps on top of one another into one column. So I'm going to kind of do it with brute force here. I'm going to say Control C and then Control V. And then I'm going to do it for the third one. So instead of having 3 columns of 4, I have 1 column of 12. And then I'm going to come in and double check and then just get rid of these 2 columns. And I'm going to come in now and I have a second column. So let's go here and rename this column so I can remember, and just call it sales. And then I'm going to come here to our second column, and I'm just going to create what I kind of call an indicator variable, a nominal variable here that will kind of, and you see I'm just putting the first 4 were sales rep 1, the second 4 were sales rep 2, So fortunately, this is not a big data set, so this won't, not too much to kind of get it. It's worth it to have it in our Guru. It does a lot of work for us. That's quite messy with an ANOVA table. So these are my 3 sales reps. And I'd like to come here and rename. So I'm clicking on this little 3 lines, and it allows me to rename that one as person. So these are the people named 1, 2, and 3, and then there's their sales. So I feel pretty good about this. This is my data. What I'd like to do now, because I did a lot of manipulation to the data, I'm going to go here and click on this little box next to the search, and it says variable properties. I'm going to click on that and then choose variable properties and kind of get an idea. If I click on sales, it does recognize that as numerical or quantitative. That's good. If I click on person, it recognizes that as nominal because I put the words 1, 2, and 3. So I was just making sure it understands the data I have changed. So this is very good. All right, so let's go to our, we need to save the data set. Call this robot sales. You can call it anything you'd like and just click save as. All right, it doesn't like my name. We'll just name it something different. For some reason, let's call this robot. There we go. So that's our data robot, and we're going to go to analytics, analysis, ANOVA. All right, so it doesn't look like we have much to put in here. Let's first select a data set, and we call that data set robot down here. And so now it has our data. The numerical value here is a response, and it's reminding you it's numerical, and that's our sales. And then the factor is what's going to distinguish each salesperson from the next, which is person. And this is completely, our significance level is 0.05. That's the default, and that's what ours happens to be selected as. I'm going to come here to diagnostics, and I'm really just looking for a visual of my data since I really haven't looked at it yet. So I'm taking away these. This is completely optional, and I want to have a little box plot there. And we have our report. So we have just a little summary of what I have here, 12 data values. Each salesperson has 4. That's good. Now, the ANOVA table is what I really want to look at, and here it is. So here is our factor person. And we can see if we come over here that the F statistic or the F value for this is 0.9285, etc. So it's close to 1. And our probability value, that's what this means here, is 0.4299, etc. So we can see that we have quite a sizable p-value here. So I want to make sure I write these down when I go to my next slide. And I chose the box plot. Let's take a look. So here are our 3 reps. You can see there's a little bit of difference in their sales, but that ANOVA test is going to tell us whether this difference is due to chance or it's a significant difference. So we'll see when we go back and make our decision. But right now there's a subtle difference, but I don't know if that's enough to fully reject the null hypothesis. So our F statistic was there for us in our Rguroo, and it was 0.929. And then our probability value, which is going to help us make a decision, is equal to 0.4299. All right, let's put these side by side. I'm notorious for just being very routine about this. Our significance level was 0.05. So I really want to think about which of these quantities is in fact larger. Is it 0.4299 or is it 0.05? I think we all agree that the p-value is greater than alpha. So our significance level was 0.05, and that way we're going to call things unusual and noteworthy if things are smaller than 0.05, but in fact ours is larger. So what that says to me is that we have some interesting results here, but they're not strong enough to reject the null hypothesis. In other words, we fail to reject the null. So in the end, we need to keep, keep this idea that they're equal, and this notion of difference, at least a significant difference, has been sort of taken away because we have to keep this null hypothesis that's been assumed true. So our statement would look something like this to finish this out. The sample data suggests that there is not a significant difference in the average selling prices that the three sales reps have been able to negotiate. So this is how we use the ANOVA function in our Rguroo to help us about solving one. It's super powerful, little work on the front end with the data, but it will save you a significant amount of time in hand calculations.